All right. Yeah. Good day, everyone. Good day from wherever you're watching from. My name is Evi Flabagasta. Or you can call me Edwin Gasta. Anyone you call, I will answer. So, we're going to be bringing a whole lot your way, and so we are starting with chemistry series, and I'm very much aware that a whole lot of students are struggling with chemistry. A whole lot of students are struggling with the understanding of some aspects of chemistry, if not most of the most important aspects of chemistry. And so we have kind of started this series so that we can be able to demystify the so-called almighty chemistry by the students of secondary schools and perhaps year one students of the universities. So like I said before, my name is Edwin Flabagasta, or you can call me Edwin Gasta, and I am a biochemist, of course. So let's dive into the matter. So today we're looking at electrochemistry. You know, a lot of students might be wondering right now, which one is electrochemistry? Because what you have in your textbook for your level is actually electrolysis. That's what you are conversant with. But when we talk about electrochemistry is simply a relationship. It's simply a study of the relationship between electricity and chemical reactions. Alright? So that's the study of the relationship between electricity or electric current and chemical reactions. So electrochemistry is simply the study of the relationship between electric current and chemical reactions, right? So this is what we study about under electrochemistry. So, but if you look at these definitions, there are two things to take note of, which is the electric current and the chemical reactions. So, from that, we have two things or two major aspects that we study under electrochemistry, which you can see here. So we can study the interaction that happens when electric current is used to decompose chemical reactions or chemical compounds. Let's say chemical compounds, which is what we call electrolysis, right? This is what we call electrolysis. And also, we can also try to understudy how that we can generate electric current from chemical reactions, which an example is what you have in voltaic cells, right? What you have in voltaic cells. But voltaic cells is not our focus for today, right? I hope you're following me. Voltaic cells is not our focus. Our focus today is the electrolysis aspect of this electrochemistry. So let's talk about electrolysis. Definition of terms. We'll be looking at electrolysis. We'll be looking at electrolytes and non-electrolytes. That's the difference between the both of them. We'll be looking at the electrodes, which under the electrodes we have the anode, we have the cathode also. And then we'll be looking at the electrolytic cell or the setup, electrolytic setup, right? We'll also be looking at the ionic theory postulated by Arrhenius. And then we'll also be looking at mechanism of electrolysis. How does electrolysis happen? What actually takes place when you talk about electrolysis happening? Then we'll also be looking at preferential discharge of ions when you are you are doing electrolysis. How does ions discharge to the anode or the cathode? What happens, or what is the thing that determines which one will go to which, or which one will go to the other? So we'll also be looking at Faraday's laws of electrolysis. Faraday made comments about electrolysis and which he practicalized, and of course it's a universal thing. That's why we call it laws, Faraday's laws of electrolysis. Then we'll look at a few questions, past questions, especially jam past questions, which is here with me. So let's dive into the case ASAP. Alright, now come with me. Electrolysis. What is electrolysis? As the word implies, you have two things here. You can see we have electro and then we have lysis. The word electro simply means electric current. The word lysis simply means to break down. So if you talk about electrolysis, it simply means the breakdown of a compound using electric current. That is the simplest definition of it. The breakdown. So let me clean this. I believe you have written this. So let's look at it now. So electrolysis is now electro derived from electric current. Then the lysis part of it simply means to break down or to decompose, right? Decompose. So if you say electrolysis is simply defined as the decomposition of a compound, or what we call electrolyte, using, or let me put it more of in a better way. So it's simply defined as the decomposition of a compound, or what you call electrolyte, brought about by passing a direct current into it, right? So this will be the simplest definition of electrolysis, that is simply defined as the decomposition of a compound or electrolyte brought about by passing a direct current into it, all right, or through it. So now this electrolyte that we're talking about, or this compound that we're talking about, it could be in liquid form, it could be in aqueous form, it could be in a molten form also, molten form. So this is the forms in which the electrolyte can be, or the compound that we are decomposing can be in, so that by the time you pass electric current. Now, the reason why they have to be in either in liquid form, aqueous form, or molten form most times is so that we can have access, so that there can be access to build those ions. Because most compounds, although there is an alteration because of the modern theory, or modern ionic theory actually, which we'll still talk about later after now. But you have to understand that is to be able to see or to have the ions in their movement form, right? Because once there is the movement of the ions, that's how electricity or whatever is generated and all of that. So now let's proceed. So what are electrolytes and what are non-electrolytes? When you talk about electrolytes, like I've said, they are liquid or aqueous or molten compounds that can allow the passage of electric current. Those liquid, aqueous or molten compounds that can allow the passage of electric current, that is what we call electrolytes. And then what are non-electrolytes? Just like the word non means they are not electrolytes. So the ones that are not electrolytes simply means that they can be liquid, they can be aqueous, they can be molten, but they don't allow the passage of electric current. So as such, you call those ones non-electrolytes. And most organic compounds are actually, in fact, organic compounds are mostly non-electrolytes. For example, you have the ethanol there. Ethanol is not. It can't allow the passage of, we have tetrachloromethane, etc. These guys, ether also, they don't allow, even benzene, they don't allow the passage of electric current. So as such, we call them non-electrolytes. But those ones that can allow the passage of electric current, like your acidified water, like your salt solution, those ones are also regarded as what? Electrolytes. They are regarded as electrolytes. So having distinguished between electrolytes and non-electrolytes. Now let's look at electrodes. What are electrodes actually? Now electrodes are simply they are solid materials that conduct electricity, or that allows the passage of electricity. Are you getting it now? So now these materials could be in the form of wires. They can be in the form of wires, they can be in the form of rods, they can be in the form of plates and all of that, etc. So all those solid materials like wires, your rods, plates, like your copper wire, for example, they are all electrodes. Like your graphite, they are like your platinum, carbon rod, and the rest. So they are all electrodes. Now, since that we've known what electrodes are, now the electrodes are now segmented into two, because there are some electrodes that can allow or that are connected to the positive terminal of your electric source, which is your battery or your generator, right? And there are these ones that are connected to the negative terminal of the battery. So because of that, we now have two classes or two types of electrodes, and those two types of electrodes are the anode and the cathode. All right, so the anode is known as the positive electrode, while the cathode is known as the negative electrode. Right, negative electrode. So let me clean this place so that we'll continue there. Now, I hope you are following the lecture. Alright, now having spoken about the anode, we want to see what makes the anode the positive electrode and what makes the cathode the negative electrode. Now, let's look at the anode. What is the anode? Which we say is the positive electrode, right? Now, the anode is simply the positive electrode because the anode is connected to the positive terminal of the battery in an electrolytic setup, right? So simply because it's connected to the positive terminal of the battery, that's what makes it the positive electrode. Now, if you connect the anode can be any of the conductors, it can be any of the electrodes. Are you getting it now? So what actually makes the difference is where you connect it to. So the moment you connect, whether it's a carbon rod, whether it's your copper or anything, anywhere you connect it makes the difference. So if you connect it to the positive terminal of the battery, automatically it becomes your anode. That is the positive electrode. So if it becomes the positive electrode, that means there is an implication. The implication is that the anode, being the positive electrode, is the path through which conventional current enters the electrolyte, or through which electron leaves the electrolyte. So it is the path through which conventional current enters the electrolyte, or electron leaves the electrolyte. Right? So the anode is the positive electrode, or the path, the positive electrode, or the path through which conventional current enters the electrolyte or electron leaves the electrolyte. So that is the anode, and like I told you before, the anode is the electrode connected to the positive terminal of the battery or your generator or electric source, right? So that is the anode. Now, having spoken about the anode, and also by the time we proceed further, you will see that in electrolysis oxidation reduction reaction takes place, and at the anode there is a type of reaction that takes place at the anode during electrolysis, and that one is oxidation. So oxidation takes place at the anode, oxidation reaction takes place. So note that oxidation reaction takes place at the anode. Now I will tell you why as we proceed. But note this is usually a jam question. This is usually a jam question because most times students don't know what this means or what actually happens at the anode during electrolysis. So you need to understand that because of what happens at the anode during electrolysis, oxidation reaction takes place at the anode. Now we'll discuss that later. Alright, let's proceed further. Now let's talk about the cathode. Remember, we're defining the terms. Let's talk about the cathode. Now the cathode is known as the negative electrode. Why? Because it's connected to the what? To the negative. So the cathode is the negative electrode, simply because it is connected to the negative terminal of the battery. Alright? So that's what makes it what? The negative electrode. Now because it's connected to the negative, alright? Now remember that electron is negatively charged, right? So if electron is negatively charged, now look at it. Remember that for anode we say it's the positive. And remember that protons are the ones that we regard when they are going. That's what we regard as the conventional current, right? Because that was the first that was discovered actually when electricity was discovered. So it was thought that what was moving was proton, not electron, right? Before electron was actually discovered to be the one moving to cause the generation of current. So that's what we say. So because anode is the positive, it means that the proton flows in through it, while the negative leaves through it, because the negative is attracted to it. Alright? Remember the law of electromagnetism. So that is what is playing out here. So if that is the case, now this cathode will be the opposite of what is happening here. Do you understand that now? So if cathode is if the anode is the positive electrode, the cathode is the negative what? Electrode, simply because it is connected to the negative terminal of the battery. Take note of that. It is connected to the negative terminal of the battery. Now because it is connected to the negative terminal of the battery, that means that the cathode is the negative electrode or path through which conventional current leaves. Do you get that? So it is the path through which conventional current leaves. Do you understand that? Leaves the electrolyte, or electron enters the electrolyte. I hope you're understanding it. So it's as simple as that. It's as simple as that. There is no difficulty there. Just connect. Once you connect to the battery source, the one that is connected to the positive terminal of your battery becomes what? The anode. The one connected to the negative terminal of the battery becomes what? The cathode. As simple as that. So now, if you look at these two things here, now, if oxidation reaction takes place at the anode, what do you think will happen at the cathode? It is very simple. At the cathode, reduction reaction takes place. Remember, reduction reaction takes place at the cathode, whilst oxidation reaction takes place at what? At the anode. Now I'm going to show you from the past question. You're going to see it because it's right here in the past question. So, but please take note of that. Now let's proceed further. Let's look at an electrolytic cell, or what we call, initially earlier it was called voltameter. So, but now we call it electrolytic cell or an electrolytic setup. Now let's look at that. So let's see a sketch of what it looks like. Let's say this is your beaker, and then your beaker you have, okay, so let's say here is plus, here is negative. So if here is plus, then here will be your anode, right? Here will be your anode, then here will be your cathode. Remember, the cathode is the negative electrode, right? Cathode is the negative electrode, the anode is the positive electrode. So now this is your so let's say this is your so let's say inside here, what you are seeing inside here is your electrolyte. Your electrolyte. Now this electrolyte could be, let's say this is sodium chloride dissolved in water, alright? Sodium chloride dissolved in water. So this is what you have here, which is your salt solution. So your salt solution is actually an electrolyte. Now, why is it an electrolyte? If you look here, you see that sodium ion is there, right? Chloride ion is there, hydrogen ion is there, oxygen ion is also there, right? So these are the stuffs that you can find inside this place. Now, let's look at something very important. So this could mean your electrolytic setup, alright? This is your beaker. This is your beaker. Now this is your wire, right? This is your battery here. This is your battery source, or your battery, your electric current source. So that's there. So now inside there is the electrolyte. Alright, let's continue. So let's continue. Now, let's look at the ionic theory. The ionic theory. We'll still come back to this, but let's look at the ionic theory. Now, Arrhenius said something. Now, in 1887, Arrhenius made a comment about electrolysis. In his study of electrolysis, he said something about these ions that are dissociated. Now, he spoke about dissociation of ions. When a compound dissociates in water, you know, because there are most compounds, let's say like HCl, which is a molecule, you know, is a molecule, not ion. So how do they form ions, or how do they produce ions? They can only produce ions when they dissolve in water. Are you getting it now? So we have to dissolve them in water to produce ions. Now, just like this salt also, although according to the modern theory, which you're going to see, that this salt in its molten state or in its solid state, it still possesses its charges, its electrical charges, right? Yes, which is its ions actually. So now looking at that, Arrhenius said that, for example, if this salt is like this, that when you dissociate it in water, it's going to, when you dissolve it in water, it's going to dissociate into something like this, right? So, but the modern concept is now saying that even when you do that, that even without doing that, at this state, at this solid state, it still possesses its what? Its ions or its charges. Are you getting it now? So now this is the Arrhenius concept, and this is the modern ionic theory. So although the modern ionic theory is, will I say, the most correct, but we still use Arrhenius concept for convenience sake or for simplicity. So we still consider the both of them. Either ways, you are still correct. Is that alright? So Now let's proceed further. So that is the ionic theory. Now when you dissolve these guys, when you dissolve this salt, for example, in water, and then ions are generated, or ions are actually produced. That is ionization anyways. That process is called ionization. Now, when that happens, let's look at mechanism of electrolysis. Under mechanism of electrolysis, what are we looking at? We're looking at what is actually happening during electrolysis. Now, for mechanism of electrolysis, you need to understand what actually happened before the introduction of electric current and after or during the process that electric current has been put in place and the electric current is entering the electrolyte. What is actually going on with respect to the electrolyte and the anode and the cathode, right? The electrodes. Now, let's look at that. That is what we're looking at under mechanism of electrolysis. So in this case, what happens? When you put your salt solution inside your beaker, for example, at this point that you have dissolved the salt in water, what is happening? The ions dissociate. The compound dissociates into ions. So immediately it dissociates into ions, they will be moving randomly. They will be moving randomly. So while they are moving randomly, they don't even know, even though you put your anode and the cathode, they don't know the one that is the cathode, they don't know the one that is the anode. Do you understand that? Because there is no attraction. There's no attraction. So looking at that, so now, but when you introduce electric current, what happens? Immediately you introduce battery or you introduce electric current into this setup. What happens is that as the electron enters and conventional current enters or all of that, now once it begins to happen, you find out that these ions will begin to have direction. So immediately you put the electric current, it impacts directionality on the ions. What do I mean by the impartation of directionality? What it means is that, remember the law of electromagnetism, that unlike charges attract, but like charges does what? They repel, right? So now, because of that, as you introduce this electric current, remember that there are positive and negative charges here, alright? So as they are entering the electrolyte, they are telling these guys, okay, now there is a direction. So because of that, sodium ion, let's say that sodium ion and hydrogen ion, they are these positive ones, whilst chloride ion and oxygen ion, they are all these negative charges you are seeing here, right? So immediately, now remember that the anode is the positive electrode through which what? Conventional current does what? Enters the electrolyte, while electron leaves the electrolyte. So the electron enters through the cathode into the electrolyte, alright? So once that happens, once electron enters into the electrolyte, what happens immediately is that sodium ion and hydrogen ion, they will become the ones that are supposed to be discharged. Now, remember that these guys are metals, right? Remember that these guys are metals. And metals are called what? Cations, is it not? Meaning cathode ions. Why are they cathode ions? Now, remember that these metals that are carrying charges like this, at this point, this is sodium ion. This sodium ion is not the same as sodium, your metallic sodium that you know. Now, this is ionic sodium. This is metallic or a neutral atom of sodium. Please take note of that. This is very, very important. Now, because this is where you understand why oxidation takes place and why reduction takes place. You must understand this. Now, also look at this guy. This guy here, hydrogen ion, is like a proton here. It's like a proton here because hydrogen hardly loses their what? Their one single electron. So, but if they do, that they become what? Just proton. So now, looking at this here, you will see that the both of them have positive charge, and the both of them, one is supposed to be discharged at the cathode. Only one, not the two of them should be discharged. So one should be discharged. So there is a factor that determines, or there are factors that determines the one among the two of them that will be discharged at the cathode, and between chloride ion and oxygen ion, which one will be discharged at the anode? Because these guys are called anions, which means what? Anode ions. So either of them must be discharged at the anode, either of these two must be discharged at the cathode. So there are factors that determine that, and that is what we call preferential discharge of what? Ions. Are you getting it now? So now that is that. So we'll look at that when we come there. So, but at this point, because that electric current has been introduced, so these guys will begin to look for what? For cathode. So when they get to cathode, there will be a competition between the two of them as to which one will be discharged first, and the other one will be left in the solution or in the electrolyte, right? So now between the both of them, we will consider the one that will be discharged. Now the same thing goes in here. Is that all right? Which one will be discharged? Now let's look at preferential discharge of ions. Now under preferential discharge of ions, this is amongst the two of them that are competing at the cathode. Which one will be discharged at the cathode? Among the two of them competing at the anode, which one will be discharged at the anode? Are you getting it now? So now, to establish that fact, the one that will be discharged, then we look at the preference. So what are the preferences? There are three major preferences or preferential discharge of ions. And those three, one is what we call the position of that ion. The position of the ion in the electrochemical series. Now let me clean this space. Now pay attention. Now stay with me. Now, so one, under preferential discharge of ions in the electrolytic setup. So one, we have the position of the ion in the electrochemical series or cells. Let's call it series, right? Remember that the electrochemical series we're talking about, we have the electrochemical series of metals and we have that of non-metals. Now, I'm going to teach you how to remember this, because without knowing the electrochemical series of metals and non-metals, you can't be able to solve certain questions in electrolysis. As long as electrolytic calculations is concerned, you must understand this and you must know their right ions, alright? You must know it. So let me teach you that, let me use this opportunity to teach you that, then we continue. Now let me use this opportunity. Okay, let's see. I'm looking for where to clean. Okay. Okay, let me clean here. Let me clean here. Now let's look at that. Now please, let's look at, for metals, the electrochemical series of metals. Now under this you have we have potassium, okay. So now I'm going to show you this. So now this is it. Now we have potassium ion, we have sodium ion, calcium 2 ion, sorry, magnesium 2 ion, aluminum 3 ion, zinc 2 ion, iron 2 ion, tin 2 ion, lead 2 ion, hydrogen ion, copper 2 ion, mercury 2 ion, silver ion, and gold ion. Now, if you look at this, and also please, you need to understand this very well, because by the time we get to metals and its compound or metal extraction, you understand that you need this. Because if you don't understand this, you will not understand the metals that can be extracted from their ores using electrolytic method. Are you getting it now? So now you understand that potassium ion is the most electropositive ion here. Potassium ion is the most electropositive ion, whilst gold ion is the least electropositive, or is regarded as inert. These guys are regarded as inert metals. They are inert simply because they are unreactive. That's why we call them inert. They are the least reactive metals. Are you getting it now? So you must understand this. Now looking at this, let me teach you that you can use this to remember this. Popular scientists can make a zoo in the low humid country more satisfactorily good. You can use that mnemonics to remember this. Let me write it down. Popular for potassium, scientists can make a zoo in the low humid. Good. Okay, so popular scientists can make a zoo in the low humid country more satisfactorily good. Alright? So this is the mnemonics that you can use to be remembering the electrochemical series of metals. Is that alright? So now, having said that, if you look at this, you will see that potassium ion is the most electropositive ion here, whilst gold ion is the least electropositive. And most times gold and silver and those guys, platinum, they are regarded as inert metals. Why are they regarded as inert? Anytime you hear the word inert, inert simply means unreactive. It does not react. Are you getting what I'm saying now? So because they are unreactive, that will also help you to understand how they are extracted by the time we start talking about metals and their compounds and how they are extracted from their ores and all of that. So please stay tuned for that class. Let's anticipate that class. Now let's proceed further. Now our interest, our focus is that we want to know between sodium ion and hydrogen ion, which one amongst the two will be discharged at the cathode, because we have established the fact that not two of them will be discharged. Is that alright? One will be left at the electrolyte, in the electrolyte, the other one will be what? Discharged at the cathode. So the principle that governs this, according to this number one, according to their position, is that the more electropositive or the most electropositive ions will not be discharged from the electrolyte, but the least electropositive will be discharged from the from the electrolyte to the cathode. Are you getting it now? So because of that, you simply see that sodium ion is high up in the series, right? Which means it's more electropositive. Look at hydrogen ion where it is, meaning that it will be discharged because it is the least electropositive between the both of them, the both ions. So we have established that. So hydrogen ion is discharged. Now, since that hydrogen ion will be discharged here, now the hydrogen ion has come here, so it will not be discharged as an ion. It has to be discharged as a neutral element, as a neutral substance. Are you getting it now? So to be discharged as a neutral substance, that means that a reaction has to take place, which in this case is called the reduction reaction. And how does that reduction reaction take place? Remember I told you earlier that at the cathode, reduction reaction takes place, but at the anode, oxidation reaction takes place. Now, looking at that, look at, now, since that this hydrogen ion has come here to be discharged, now it's still an ion here. Since there is an ion, to convert it to a neutral substance, that means it has to gain electron to become stable, or to become neutral. So that gaining of electron, that process of gaining electron at the cathode is what we regard as reduction reaction. And I told you that reduction simply means gain of electron. That is the definition of reduction in terms of electron transfer. Do you understand that now? But oxidation simply means loss of electron in terms of electron transfer. Are you getting that now? So we have concluded that now. So hydrogen has been discharged. Now let's look at the non-metals here, the two of them, one of them will be discharged also alongside what? One of them will be discharged at the anode, just like hydrogen has been discharged at the cathode. Are you getting it now? Because both of them are going to interact to form a compound at the end of the day, so that we know that a compound has been discharged from this electrolytic setup, and a compound have to remain in the electrolyte. Is that all right now? So now let's get to the next. Let me clean this so that we'll look at let's look at the electrochemical series of non-metals. Look at it here. Electrochemical series of non-metals. So under here we have now, this is the non-metallic electrochemical series. Under that, you have the least here. This is the least electronegative, which is what? Hydroxide ion. Then this is what? The most electronegative. So now, if you look at the both of them, also the same principle applies. The more electronegative will hardly be discharged. They are mostly not discharged from the what? Electrolyte. But the least electronegative will be what? Discharged at the anode. Do you understand that now? So looking at that now, let me also teach you a mnemonics you can use to remember this. A mnemonics you can use to remember this, which I coined, is hydroxide is brother Clement, not so far. Hydroxide, is brother Clement, not so far. That's the mnemonics you can use to remember the non-metallic what? Electrochemical series. Is that alright? So looking at that now, our interest is what? Chloride ion and what? Oxygen ion. Which is what? Now, sorry, not oxygen ion, sorry, hydroxide ion, sorry. Hydroxide ion, right? Please correct that. Now, hydroxide ion. So we are looking at these two. So between the both of them, which one is more electropositive and which one is the least electronegative, sorry. So you look at this, you find out that hydroxide ion is what? Is the least electronegative here. So that means it will be discharged over what? The more electronegative, which is what? Chloride ion. So that means that at the anode, when the two of them compete, hydroxide ion will be what? Will be discharged at the anode. Now remember, it's still an ion here. And if it is an ion, how would we, or how are we going to make it to come to neutral? Or what is going to happen? Remember that if you talk about non-metals are usually what? Anions, which means that non-metals gains electron. Which means that this guy has gained an electron. Are you getting it now? If this guy gained electron, to make it neutral here, he has to what? He has to lose the electron. Are you getting it now? To take it back to normal, he has to lose what? The electron. So at the anode, there will be what? Loss of electron. So once there is a loss of electron at the anode here, that is what we define as what? Oxidation. So we say oxidation reaction takes place at the anode because there is what? Loss of electron. Remember, there is what? Loss of electron. So that is what? Oxidation. So please take note of this. These are JAM questions. JAM like asking questions from this place most of the time. Every year you must encounter a question on what? Electrolysis, and it's from this either oxidation or reduction, which one takes place at the cathode. And they can also ask you, they can give you a particular compound and ask you what will happen at the anode and what will happen at the cathode. Or they will ask you which one of these, out of this compound, which one of these ions are going to be discharged at the cathode, which we are going to see now from the past question, and which one is going to be discharged at the cathode. Do you understand that? So please, if you know this principle, especially this one, the position of the ion in the electrochemical series, you are saved. Is that alright? So please, may the Lord give you understanding. Alright, let's proceed further. Now, so that is just that. So at this point, what do you think we have produced? When you react these two guys, that will give us what? That will give us water. Is that alright? That will produce water. So it means that water has been what? Discharged. Whilst what? Sodium ion plus what? Chloride ion, which will what? So salt will remain in what? Salt will remain, that sodium chloride will remain in the what? Electrolyte. It will not be discharged. Please note that. That's an exam question. They usually ask for this salt solution. Yes, so please note that. Now, another example is that you can do an electrolysis of acidified water. Now, let me show you a question. Let me show you a particular question. Now, look at this question. Look at this question here. Let me show you this question. Look at this question. It's a question on electrolysis and it's JAM question. The question says, let me show you. Let me show you. Let me show you. The question says, question number 1, that's 2009, question number 18. It says, the acid used in electrolysis of water is dilute. Are you getting it now? The acid used in electrolysis of water is dilute what? Now, there is what we call the electrolysis of acidified water. When you hear acidified water, this means 2 drops of H2SO4 in water. This is a dilute water, or you call it acidified water. So that is what they are asking you here. But the way they presented the question, in an example, the student might be wondering, what is it all about? Because they didn't mention what? Acidified water. Are you getting it now? So the answer here should be H2SO4. A says HNO3, B says CH3COOH, C says H2SO4, and D says HCl. Some students might go and choose HCl because it's an acid. Maybe they know that this is acidified water and they think it's an acid. So the answer here is what? H2SO4. So we're going to continue to answer most of this question in our next class. So please guys, I want you to study all of this very well. So in our next class, we're going to be considering Faraday's laws of electrolysis. Alright, so please guys, I want you to do me a favor of liking, commenting, and of course subscribe to this channel, right? As we bring you exciting classes on this YouTube channel. That's alright? Thank you so much. Thank you. Thank you.